So today we're going to be looking at Unit 7 and specifically Module 31, which is how we study and encode memories. Specifically, we're going to look at 31-1 and 31-2. So how do we define memory and can we explain how it's measured? Memory is defined as the persistence of learning over time. That's one half of the definition. So it's something that has to kind of be hanging out, right? Over a period of time, and then using the process of encoding, storage, and retrieval, which we'll get into in more detail later. So how is it measured? It's measured through recall, recognition, or the amount of time that it would take us to relearn information that we had already learned once. So let's dig into that a little bit more. How is memory measured? How do we know that something is in our memory? Well, there are three ways. The first one is recall. Recall is when we are trying to pull information out of our mind that is supposed to exist using very few retrieval cues. Meaning, I might say to you, what is the capital of Wisconsin? That's an open-ended question. I didn't give you multiple choice answers. I didn't give you a word bank. So you have to kind of pull that out of your mind cold, okay, without any other indicators of where you should head for that answer. So fill in the blank questions, essay tests are very commonly asked questions for recall. Another option would be recognition. Now, how you would look at recognition is you're given a list of possible answers and you have to identify which is the correct answer. So you just have to recognize it, right? Multiple choice test or a word bank would be examples of a recognition task. I think if you guys had to choose between recall or recognition, you would probably understand that recognition is the easier of the tasks because one half of the challenge is already done for you. In recall, you have to produce a list of possible answers and then narrow it down to choose the correct answer. Versus in recall, that list of possible answers has already been generated for you. Another way that we can measure learning is through relearning. What this means is, once you learn something once, it should be easier or faster to learn it again a second, third, or fourth time. An example of that would be learning material in AP Psych for a unit test. And then when you go back to study for our College Board test in May, it should take you less time to relearn that material if you put a good amount of time in on the front end. A fun fact is that how quickly we respond actually indicates how strong of a memory that is. Okay. So, who is a key researcher tied to this? Hermann Ebbinghaus is one of the key researchers tied to this. What he had was a list of nonsense syllables, and I have examples of them there. And what he did was he memorized that list of nonsense syllables one day, and then he came back the next day to see how long it would take him to relearn. What he found was that the more time that he spent learning the material on day one, the less time he needed on day two. So the graph that you see here is an example of the amount of time spent, and then just kind of showing that as your rehearsal increases, so the more time that you spend, right, then the less time it would take you to relearn it days later. So the I can statements for Module 31 that we're going to start with are define memory and explain how memory is measured. Can you do that? What you would include to answer that question would be not only the definition, but the three ways that we measure, as well as what we know about those measurement methods. Up next will be 31-2, where we discuss how psychologists describe the human memory system. So first of all, psychologists use memory models to try to think and communicate about memory. This is all very confusing, right? So we're trying to explain something that's in your mind by getting you to learn things that we need you to put in your mind, okay? So that whole metacognition, that whole thinking about your thinking can be very challenging. So what are the models that psychologists use? We're going to look at the information processing model, the Atkinson-Shiffrin model, and then we also need to include an understanding of parallel processing and connectionism. So let's look at the information processing model. This model claims that memory works like a computer, meaning it has three things that it needs to accomplish. It needs to encode, store, and retrieve. So essentially, this model is providing us an overview of 3 steps that are involved in the memory process. So to encode means that we need to get information into our brain. Storage means we need to find a way to keep that information there. And then retrieval is we should probably get that information out, right? Because how would we know what we've learned or what we remember if it's stuck up there and we can't get it out? Now, in addition to the information processing model, there are a few considerations. It's not perfect. We aren't actually computers. We have to allow for what's called parallel processing in the human mind. What that means is that we have the ability to process a lot of things at once, and many of those are happening unconsciously, so without us even having to think about them. So, another lens that we might use to look at this would be the connectionism model. This model explains parallel processing because it claims that our memories are the result of connected neural networks. So remember, groups of neurons that are talking together in a specific way or pattern for a particular memory. So each memory has a specific activation pattern. When you learn something new, your connections in that neural network are strengthened or you form additional connections. Now, the more likely tested would be the information processing model, but it's important to at least talk about the connectionism model. So, if those are the 3 steps that we have to go through for memory, then how do we actually form memories? So, we're going to look at the Atkinson-Shiffrin model for that. In this system, there are 3 stages of memory. There's sensory memory, short-term, and long-term. Sensory memory is first recorded as a really, really fast and very quickly fading sensory memory. Now, if we notice that sensory information, if we pay attention to it, then it has the potential to get into short-term memory. So think about it. There are lots of sounds, there are lots of sights, there's lots of smells, right? All of these things are coming at us all of the time. Maybe you're in a crowded lunchroom or a crowded classroom or a loud house. And so there's a lot of noise going on. So all of that is coming into your brain. But what are you hanging on to? Is all of it getting into your short-term memory? Of course not. The stuff that you choose to pay attention to, you would have the potential then to move it from sensory to short-term to long-term. So let's say that we pay attention to something. We're in a loud environment. We hear somebody yell our name and we turn our head and suddenly we're paying attention. So that bit of sensory information that was coming in, we chose to recognize and say, this seems personally important. That's actually called the cocktail party effect. So we put it into our short-term memory, right? Now, short-term memory has a longer duration than sensory memory, meaning it can be in there longer, but it has a smaller capacity. Okay, we're going to talk about that in future videos, but it's 7 plus or minus 2 bits of information. We need our short-term memory because that's what we use to encode information. Okay, so let's say that we do that. Let's say that we spend time rehearsing information, right? We're going over and over it. Then it has the possibility to make it into our long-term memory. Our long-term memory is limitless. So you're never going to run out of storage, okay? The idea is that if we bring that information in, if we've spent some time on it in short-term memory, that we hopefully get it into our long-term memory so it's there if we need to recall it in the future. This is kind of a simplified version of this model, and our future lessons are going to spend more time going into greater detail on each one of these stages. So what changes exist? What are the updates to this model? Well, one update is that this model doesn't really account for automatic processing. We know that our brains automatically process some things, meaning you don't really have to spend time getting it from short-term into long-term. It just sort of goes there. The other update would be working memory. So short-term memory and working memory, we're going to kind of think of as going hand in hand. In the short-term system, we're actually using it as a workspace, right? We have to do something with the information to get it into our long-term memory. So the update to this model would be that we would kind of talk about short-term and working memory as sort of the same stage. And we do this to remind us that we're doing work with the material. We're trying to link our new information, our new learning, to anything that already exists in our long-term memory. So a visual way of looking at this If you look at the graph at the top, to the left, we see that there are external events or sensory input. So that's where I was talking about how there's lots of things coming at us all the time, okay? And many of those things are in and out of our sensory memory, okay? But we have two options once they're in our sensory memory. The first option is to pay attention, okay? Now, usually we pay attention to things that seem important or new. So let's say that we spend some time paying attention to the material. This would be the beginning process of encoding. So then that information could go into our working or short-term memory. And the more that we use it or we rehearse it or we try to do something with it, the more likely then that we continue encoding that information to get that information into long-term memory. If it makes it into long-term memory, then we have the ability to pull it out, which is called retrieval, to use it again in the future, whether that's to pass a test or to learn new material by linking it to what already exists in our long-term memory. Now, the only part that we haven't talked about here is that whole automatic processing thing. So let's look at that. You go back to the sensory memory box. And again, I said there's lots of sensory input coming in at any given time. You're not going to pay attention to all of it. But sometimes things just automatically go into your long-term memory, all right? And we're going to, again, learn more about that with future reading and future videos. So two options, encoding because we pay attention, or automatic processing, which ends up in long-term memory storage. Now, the chart near the bottom, that's actually just giving us a little bit more information about the guy who is the founder or who coined the term working memory. So that's Baddeley. And this is just showing us what he's talking about, okay? Like, what was his point with working memory? So the idea that we have to have this central executive, like a place where all of the information kind of filters through, and we do work with it. Now, sometimes we're going to do auditory work with it. So it's something we hear and we're going to rehearse it and go over and over. Other times, it might be something that we see or that we physically do. And again, our central executive or our working memory, its goal is to do work with it so that we can get it to long term and then pull it right back out. So if you're looking at this box, I'm not trying to confuse you even more, but you could sort of take this whole box with all these three circles here at the bottom, and you could sort of just put it right into the working or short-term memory box in the middle. So this brings us to the end of the I can statements that we're covering for today. Can you discuss how psychologists describe the human memory system? In order to do that, you would have to include all of the information about the information processing model and the Atkinson-Shiffrin model, as well as be able to go into some detail about working memory. Coming up next will be our ability to describe the differences between explicit and implicit memory. Again, this is just a short video to kind of go over the basics of the human memory system.